Good morning. Today we are going to do experiment number 7, resistors and capacitors. To begin our experiment, we need some materials. Those are, first of all, we need a power supply. We need a plug-in board, an ammeter, a voltmeter, and 3 different resistors. And finally, we need a capacitor. We need also some connecting wires. Let's begin. First of all, we are going to begin with the first resistor, R1. First of all, we are going to use the first resistor, resistor number 1, and we need to measure its resistance. To do this, we put it on the plug-in board, and we connect it to the power supply and to the ammeter, and we put the voltmeter. As you know, the ammeter must be plugged in series and the voltmeter in parallel. To do this, first of all, we put this one here, like this, and we put it here like this. As you can observe, now the ammeter is in series with the resistor, and we exit the ammeter to put it like this. Now we are sure that the circuit can exit the positive terminal from the power supply, enter the ammeter, exit the ammeter and enter the resistor, and finally go back to the power supply. Now we need this one, which is the voltmeter. The voltmeter must be plugged in parallel. To do this, we need 2 other connecting wires. We put this one here and here, and we use the ground terminal from the voltmeter, and we connected it like this. So as you can observe, now the voltmeter is plugged in parallel with the ammeter. Now we need to do some measurements. To do this measurement, first of all, I turn this one on 0, turn the power supply, and let's change the voltage delivered by the power supply, or the difference of potential, in such way that this value will not exceed 5 volt. So let's use the direct current option in the voltmeter and put it on the 5 volt. And here, let's put it on the 30 milliampere. Now we turn this one in such way that we get a value close to 1, 2, 3, 4, 5. Any value can be used. Now we have here almost 1.3 volt, but the reading must not be done on the power supply, but instead on the voltmeter. As you can observe here, if I make my reading, the scale chosen here is 5 volts. That's why I'm going to make my reading on the above scale. So according to this one, the value is almost equal to 1.4. So this is the value. I'm going to record this value here, 1.4 volt. And as you can observe here, the current crossing the ammeter is very, very small because the scale chosen is high. That's why I'm going to decrease the scale in such way that I can make my reading here. So the scale chosen here now is 1 milliampere. That's why I'm going to make my reading on the above scale, which is here is labeled 100. So I have to convert 100 to 1. To convert 100 to 1, I have to divide 100 by 100. When I divide it by 100, it becomes 1. In another way, whatever the value that I'm going to read here, I have to divide it by 100 to convert it to my scale chosen here, 1 milliampere. So as you can observe here, the value given by my ammeter is equal to 22.5. 22.5 divided by 100 makes 0.225. Good. That's my first value. Now, how we can do for the to find the resistance of my resistor? All what I have to do is to apply Ohm's law, according to which V is equal IR. So R is equal V divided by I. So I'm going, before making calculations of my R, I'm going to complete my table in such way that I'm going to change the difference of potential delivered by my power supply to another value. So the other value will be any other value, for example, this one, 2.3. As you can observe, meanwhile, I did several measurements, and I'm going to do just in front of you the last one. The last one, I changed the difference of potential delivered by my power supply, and I made my reading here, according to which the value is equal 4.85 volt. Now let's make my reading on the ammeter, and according to which this one is equal 77.5 divided by 100 to convert the value into 1 ampere, which this one is equal 0.775. Make the calculation of the first value of the resistance. So this one, V is equal IR, so R is equal V divided by I. So let's divide 1.4 divided by 0.225, and here, as you can observe, the value, the scale chosen here is milliampere. Milliampere means 10 to power minus 3. This one is written here, and I'm going to put it here, x minus 3. So this one gives me 6,222.22. And for sure, the unit is ohm. I'm going to do the same for the other ones. So I did the calculation of R for all values of V and corresponding values of I, and I found those values. Now, how we can find the average value and SEM? As you can observe, I can use the calculator, and I can put mode, standard deviation, mode 2. Now let's erase anything in the memory. Shift mode statistic clear 1, statistic clear equals, and let's put inside the calculator those values. 22 memory. This is my first value. 6,351.35 second value. 6,200 third value. 6,250 third value, fourth value, and now the fifth, 58.0. This is the last one. Now AC, shift 2, the average one equals, so my average value is equal 6,256.3 ohm. And the SEM, this one 2, standard deviation 3 equals, this is my standard deviation to make the calculation of the SEM, standard error of the mean. I have to divide the standard deviation by radical n. Radical n, the number of values, the size of my sample is equal to 5. So divided by radical 5, and this one gives me 25.89 or 0.9 ohm. So like this, I found the average value for the first resistor and the SEM. Now what I have to do, I have to make the same calculations for R2 and R3. All what I have to do here, as you can observe, all what I have to do is to substitute R1 with the second resistor, R2 or R3. So we take this one like this, and we put R2, and again, we do the same calculations for R2. I made my calculation, and the value is equal to 2,127, and the unit is ohm. Let me write the unit, ohm. So now we have those values. All what I have to do is to find their average and their SEM. So I did the average value and the standard deviation, standard error of the mean. Now what I'm going to do the same for the last resistor and find its average and its standard error of the mean. Once we finish with the last resistor R3, now I have to put those three resistors in series and in parallel and repeat the same procedure. So to put them in series, this is a very easy task. All what I have to do is to let me put R1 first. The same if I put R1 or R2 or R3 at the beginning. So R1 like this, and R2 here, and R3 here. And now I put it like this. So I put those three resistors in series like this. Now what I have to do, I have to repeat the same measurement as before. So choosing, for example, any value. Let's assume this value. And as you can observe, the current crossing those resistors is very feeble. So that's why very weak intensity. That's why I have to change the scale here. Decreasing the scale, decreasing one more time the scale, and now I can make my reading. So let's make the reading when they are in series. In series, here we can make the scale chosen is always 5 volts, so I have to make my reading on the above scale. So now the value is equal 1.34, 1.34, and the value of the current is equal to, according to the scale here, is 1 milliampere. So 1 milliampere, I have to divide this one by 100 again, one more time again. So 1 milliampere, the value is equal 16 divided by 100 equals 0.16. 0.16, and I do the same for the other ones, and I make the calculation of this one. So for the first value, 1.34 divided by 0.16, x minus 3, because we have here the 10 to power minus 3 ampere. So this one gives me 8,375 ohm. As you can observe, this value must be equal almost, because it's in series. So to this value plus this value plus this value. This value is very, very small. That's why, as you can observe, 6,200 plus 2,100 is equal to 8,300, almost this value. This value is very small. So this is accurate value. Now what I have to do, we do the same. What I have to do now, I have to put them in parallel. How we can put them in parallel? And this one is a little bit more difficult than previous one. So I'm going to turn this one off, take those, and let's put them in parallel. To put them in parallel, I put this one here, and this one here. Now what I have to do, I have to bring a different connecting wires. Plug this one from here till here, and from here till here, and from here till here, and from here till here. Like this, they will be in parallel. So bringing a wire. So first of all, from here till here, like this. Okay. And another wire, another black wire, and from here till here. Now, from the right hand side, they are in parallel. They are in parallel. I will do the same from the left hand side. So, bring a red one. Never mind, the color does not affect the measurements. So here like this, and another red one. So from here to here. Now those two are in parallel. From the left hand side and right hand side, they are parallel. All what I have to do now, bring those like previously. If I put them here, and the other ones, those, if I put them here, now let's check up what I did. Actually, the current flows from the positive terminal, goes inside the ammeter, exits the ammeter like this, and enters and enters through this wire to all of those resistors. It enters like this and exits from here, where it exits, according to the blue wire, it exits to the power supply. So we have a closed circuit. And the ammeter, the voltmeter is always put in parallel. Okay, that's everything. Now what we have to do is turn this one on, and because they are in parallel, the equivalent resistor or the equivalent resistance is smaller than the smallest resistance or resistor. That's why we have to change the scale one more time again, and choosing a value here, let's assume 1. As you can observe, this is a very big current flowing through those resistors. Again, I'm going to change the scale, and now let's make our reading. So my reading is here 1 volt. I put here 1 volt, 1.0 volt, and this one is okay, it's accurate, it's acceptable. So this one here, we can make my reading is equal to 22, but the scale chosen here is 10, so I have to convert 100 into 10. To convert 100 into 10, I have to divide this one by 10. When I divide it by 10, it becomes 10, like the scale chosen. So all values here must be divided by 10. So this value is 22. 22 divided by 10 makes 2.2. 2.2 milliampere. Don't forget milliampere, because here we have milliampere 10. And I will do the same for the other values. So I change this one more time again, any value, and I record this value, which is equal to 2.1, and one more time here 45, which is equal 4.5, and again, and make my calculation for the first one. 1 divided by 2.2x minus 3 is equal to 454 ohm. For the second one, for example, 2.2 divided by 4.5 equals times 10 to power minus 3 is equal, again, 2.2 divided by 4.5x minus 3, 466.6. And the same we'll do, and we find the mean value and the standard error of the mean. Now, once we finish with the calculation of the resistors, each one alone and in series and in parallel, we have to skip to the last part, which is corresponding to charging and discharging a capacitor. Charging and discharging a capacitor. I need a capacitor. This is my capacitor. This is my capacitor that I'm going to use. Okay. I have to plug, according to your manual, I have to plug it with the highest, biggest resistor. The biggest resistor, as you can remember, is R1. So I'm going to take those, all of those like this, and keep R1. So I have to use this one. But first of all, we have a lot of wires. I'm going to turn this one off, and again, take all of those like this. So we don't need, in this part of the experiment, we don't need the ammeter. We need only the voltmeter. So this is the capacitor and this is R1. Let's plug them in series like this. Okay. Now take this one, the positive terminal of the power supply, plug it to the positive terminal of my capacitor like this. And the current can flow through this one and goes to the first resistor R1, and like this we have a closed circuit, so the current can flow like this and back to the power supply. Now we need to measure the difference of potential across the capacitor. To measure the difference of potential, I need only a voltmeter. I put this voltmeter like this and like this. So using this voltmeter like this, I can measure the difference of potential across the capacitor. Now I am going to, let me take this one off again. To adjust the value, I'm going to choose a difference of potential which is equal to 5 volt here, 5 volt, almost 5 volt. And all what I need, this is almost 5 volt, almost 5 volt. And all what I need is to plug this one like this. If I put it like this, as you can observe, the current will flow this one and the capacitor will be charged, will be in the process of charging. So if it will be charged, here it's very important to follow up the variation of the difference of potential on the voltmeter. Look very carefully. I'm going to plug it in like this. 1, 2, 3. It's plugged in. And look here very carefully how the difference of potential is increasing across the capacitor. So what we will need to do is, according to the table here, I have to make a charging of the capacitor, but I have to make a reading for t, the time, initial time is equal to 0, 2 seconds, 4 seconds, 6, 8, 10, 12, 14, and 16. It seems that after 16, the capacitor will be completely or fully charged. So what we need, actually, we need a stopwatch. Stopwatch, I can use the stopwatch like this, start, and stop. So reset, stop, reset. So what I need, actually, I need to start it at t equals 0, and I will not stop it until 16 seconds, like this, start. And every 2 seconds, I have to make a reading on the voltmeter here, a reading. 2 seconds, 4 seconds, another reading, 6 seconds, while this one is increasing, moving like this. So I have to make a reading, and at 16 seconds, I stop my experiment. The experiment will be finished, will end. So reset. So that's what we are going to do. Now to do this experiment, let me discharge the capacitor. To discharge the capacitor, I put this one like this. Look here very carefully. Look very carefully. So it's discharging. So what I need to do, actually, when this one becomes 0, it's almost 0. So it's almost 0. So I have to begin my experiment. To begin my experiment, this is a very, very hard experiment. So I have to put this one here, like this. I have to put it here, like this. And at the same time, I have to start my stopwatch. When I put it in, I have to start my stopwatch. And I have to make my reading every 2 seconds. So to do this very difficult task. 1, 2, 3, and this one like this. So every 2 seconds. This is a very difficult task to be done with one student. We need actually at least 2 students or more, 3 students. It will be better. So what we will do, actually, we will follow out the value here. I'm going to do it again for the last time. Let's do it for the discharging. Discharging, all what I have to do is to take this one here and put it 1, 2, 3, and look here very carefully. So it's discharging. So what I have to do is to follow up the variation of the difference of potential with time, 2 seconds, 0, 4 seconds. And this is a very hard task to be done with one student, impossible with one student. We need at least 2 or 3 students to be done. And that's everything. Once we finish this one, those 2, we have to draw the variation of the difference of potential of the capacitor with respect to time. Here we have V with volt and T in seconds. So what we will get for 2 seconds, 4 seconds, 6 seconds, 8, and so on, 10, 12, 14, and so on. 14 seconds, we will get something like that, like this one, which is called charging. For discharging, V in volt, T in seconds. We will begin from the maximum value that I will get here, maximum value, V maximum, V max. So I begin with this value, and discharging will be something like that. Discharging. And that's everything. Thank you.